Alright, this is Dr. Thompson going over the first log trig gateway. So these 5 problems, and the first 2 were to find all solutions in 0 to 2 pi of these equations. So the first one was sine squared 2x equals 1. So you have a couple options here. You can use an identity, but I think the easiest thing to do is just to take the square root. So you have sine of 2x equals plus or minus 1. And because you're going to have a 2x when you take arcsine, if you look at the unit circle, I kind of want to go twice around the circle because I know I'm going to divide by 2. So sine is plus or minus 1 at pi over 2 and 3 pi over 2. So 2x is going to be pi over 2 or 3 pi over 2. Or if we go all the way around the circle, then I guess 5 pi over 2 and 7 pi over 2. And the reason why I want those is because I have to remember I'm dividing the answers by 2. So the possible values for x are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And those are all between 0 and 2 pi. So those are the 4 possible answers. You could also have used an identity if you wanted to. Alright, so the next one, I do believe you have to use an identity. This is cosine of 2x equals cosine squared x. And probably the easiest thing to do is to change cosine of 2x using an identity to something else. And I'm going to go ahead and change it to cosine squared x minus sine squared x. Remember, those two add to 1, but cosine squared minus sine squared is cosine 2x. So I can subtract cosine squared x from both sides, and I just get this, which, if I get rid of that negative, I'm just asking for sine squared x to be 0. If I take the square root, I'm just asking for sine x to be 0. And that happens, let's look at the unit circle, y is 0 at 0 and at pi. So there are just 2 answers here. And on both of those, keep in mind you can check them on decimals. You need to actually work it out algebraically, but you can double check your answer. Okay, so the next problem here is e to the x minus 2 equals 7. Not a lot of things to do here. Just take ln of both sides, and ln and e are inverses, so they cancel, and you get x minus 2 equals ln 7. So x is going to be ln of 7 plus 2. Keep in mind, whereas sine and cosine and those functions are very periodic and they have lots of answers, e to the x and ln of x are one-to-one functions, which means that you're only going to get one answer here. There's no ambiguity when you take ln of both sides. Now, I don't mean that every problem only has one answer, just that there's no issue when you take the inverse function. So here, for example, this is number 4. I can take ln of both sides, and I get this. And however you want to do this, don't divide by x, because x equals 0 is an answer. But if you maybe write it this way, you can see that the answers are x equals 0 and x equals 1. Okay? And then the final question is pretty tough. It's a little harder than I meant for it to be, but it is doable. This is ln of x plus ln of x minus 2 equals ln of 2. So if you combine the functions on the left, because logarithms allow you to just multiply the arguments if the 2 logs were added, and then take e to both sides, you get this equation. And now you're back to polynomials in algebra. But when you solve this, you get x squared minus 2x minus 2 equals 0. And from there, I can say this is x. Well, I don't think this factors, unfortunately. So what we can do is use the quadratic formula. You can also graph in decimals to see if there really are roots. And there are. They're just messy. So you're going to get 2 answers, but we're going to have to do that with the quadratic formula here. So let me go ahead and do that on the next slide. So this is going to be, let's see, we have x squared minus 2x minus 2 equals 0. So it's going to be negative 2 plus or minus 2 squared minus negative 2 times 1. Remember, it's b squared minus 4ac all over 2a. So this is 2 plus or minus square root of 6 all over 2. Oh, Nope, I messed up, didn't I? It should be minus 4ac, so there should be a 4 here as well. So in that case, this is really not square root of 6. 4 there. This is square root of 12. There we go. And 12 is 2 square root of 3, so this all becomes 1 plus or minus square root of 3 when we're done. So those are our two answers, but this number is negative, and remember that you can't put negatives in logarithms. So if you go back, if I put that number into here, that would be a problem because I can't actually input a log of a negative number. So the only actual answer then is 1 plus square root of 3. That number is bigger than 2 as well, so I can plug it into both logarithms. Okay, I realize that was a tough one, but you guys can do it. And if you have questions, please just come ask me.